I'm glad to be here. I'm glad you're joining me on this beautiful day, best of the year so far, right? So terrific that you're here. I'm excited to talk about the weather that we're going to be coming into that season for with the spring, and we'll give you some weather, all about Illinois weather. In the name of my talk is when the wind comes sweeping down the plain. If you have any questions, if you want to raise your hand, or just actually probably best put it in the Q&A, or wait till the end where we'll do a full Q&A session. That would be great. So let me give you a little bit of background. As George did mention, we are the most comprehensive community college meteorology programs in the nation. And if you take a look at what we actually offer, and certainly people from the area are welcome to come and take any of these courses. The traditional intro to meteorology, severe and unusual weather. We do 4 different forecasting courses. We do some advanced courses, intermediate mesoscale meteorology, which is a little bit more into the collegiate, higher mathematical level. We do severe weather analysis. We do climate and global change, hazardous weather and preparedness is a very common and popular course. And then we have the Thunderstorm lab, which is our storm chasing. But the thing that we're most known for is our next lab, which is probably one of the most commonly used professional meteorological websites in the world, or at least in the nation, because we've got so much data. We'll talk a little bit about that. And we're also known for our storm chase program. So this is our website. We are specializing, and most of our traffic comes through what we do with satellite imagery. And it gives you some idea. Actually, let me go back for a second. Gives you some idea here. This is a GOES satellite. This was launched, and there's 2 GOES satellites, geostationary orbiting environmental satellite. And this is the one that's centered somewhere over the East Coast. And then there's one that's centered over the Pacific. And it gives us 24/7 data coming into us, and we're processing all that data. I'll mention something a little bit about how much we do in a second. But this is the beautiful imagery that we do generate, and that has come from this new system of satellites that we have. So we have a lot of information. I wanted to throw this out there for you. This is some of the places that use our website. If you just get some idea, we have lots of military, Navy, U.S. Air Force. We've got national forecasting groups. Every school and university that has a meteorology program uses our website for a lot of the stuff. So we really found our niche to provide the most professional quality information. By the way, I threw this as an underlay, this little image here. This is our 6 to 10 day temperature outlook. And it's showing that we are in the heart of well above normal temperatures for the next 6 to 10 days. So yay, we're happy for that. Don't get used to it. Obviously out in California, they're well below normal. And what goes around comes around. So we'll eventually get back to more normal, cool temperatures. But for a while, we're gonna have some pretty nice weather. So our website, on an average, is about 38,000 plus unique visitors a day. We have over 10 million hits, and we're putting out about almost a terabyte of information daily. And we've been doing this for almost 30 years. And I used to download with a 1200K modem. And I figured out that to get this much data on a 1200K modem takes around 17 years. So we've improved the speed over my career at College of DuPage. So I wanted to talk about some of the weather that we're going to deal with. So we're going to look at what we call the billion-dollar weather and climate disasters. And this is just something that we kind of do now. We're calling big events climate disasters, which is kind of ridiculous because these are things that happen every year. So these are truly weather. Although if you start looking at the entire year of being drought, that would be something. So this is 2016. You'll notice that we have plenty of severe weather throughout the plains. That's where tornado rallies defined. Every once in a while, we'll get them into the Ohio valleys or the east, and we'll get some big tornado events. Summer wildfires, there was a big fire that happened down in the Appalachians and the Smoky Mountains in the fall. Only one hurricane. So keep that in mind. This was Hurricane Matthew back in October of 2016. We move on to 2017, And the funny thing is we had a drought the year before. This year we have flooding, and these fires, and here's the irony, is that the fires were not a result of the drought. The fires were a result of the extremely wet season that we had, because in the typical year out in California in the West, we get growth in the plains. And we had so much rain that the plant growth was through the roof. Then, typically, as we expect, getting into the summer, it dried out, and that became kindling for these wildfires that hit that in 2017. Again, severe weather through the plains. We had a Midwest tornado outbreak. A couple more. Hurricane Harvey, one of the biggest flooding disasters in U.S. history. Hurricane Maria hit through Puerto Rico. Irma, so we had some pretty significant hurricanes that year. We moved to 2018. There we are in Western wildfires. The Southern Plains, the Southwest drought. We had some big hailstorms, tornado outbreaks throughout the South this time. Not so much in the plains, but a little bit more into what we call Dixie Alley. A couple big snowstorms. Those are big money costers. We moved to 2019, and we started getting pretty much the same thing. This year, we had a much more significant flooding going on there. And again, Hurricane Dorian and Imelda, a couple of hurricanes that came through. And then we go to 2020, and 2020, we had a pretty good fire season. It went back to being dry in California. Lots of severe weather. We had a couple of severe weather outbreaks here with the derecho that came through the upper Midwest. It did a lot of damage in Iowa, came through northern Illinois, produced a couple of tornadoes. But look at the amount of hurricanes that hit the U.S. this year. So we had a pretty active hurricane season for this year. So these are all billion-dollar weather and climate disasters. And something to keep in mind is that these billion-dollar disasters are becoming more common. And I'm going to point out something here. It's not because of climate change as much as it is because we're becoming more and more vulnerable. Our population centers along the coast are increasing greatly. We are building into wildfire regions. So a lot more damage, a lot more properties being lost by these severe weather events, significant weather events that happen. And so we're starting to see the cost in the United States going up year after year as we become more and more vulnerable. So one of the things that we want to think about is how do we mitigate this? How do we protect ourselves from these financial costs? And we can talk about that as the case is needed a little later in the talk. So we'll start with tornadoes. Now, in the United States, there are about 1,200 tornadoes in the United States a year. We are by far the #1 tornado experiencing country in the world. We have about 70% of the world's tornadoes. And this is a map from, I don't know, what was it, 61 years of tornado tracks. And it gives you an idea that tornadoes are pretty common everywhere, especially east of the Rockies. Now you might say, well, the Appalachians don't have as much. I hope you can see my cursor over here. I'm gonna do this. I can use a little tool I have here. I've got some regions over here, maybe up in New England. And what's really going on is we have a lot of forested areas, and so we may not observe tornadoes. We are observing all of these tornadoes more and more frequently. When we get into the West, big areas of dry air, there might be some tornadoes there. They're not as common. We'll talk about reasons for that. But if you look closely, you'll see that definitely the Central Valley of California is a fairly hot spot. Even Southern California, down in parts of the desert Southwest, up through Idaho, there's still a number of tornadoes. So no place in the continental US, and actually that's true of Hawaii and Alaska as well, is actually free from the threat of tornadoes. Now, if we look at tornado frequency, I want to show you what we kind of consider the main tornado alley. So this area in terms of all tornadoes, and that's sort of what we perceive as tornado alley. We can also see a pretty significant amount of tornadoes across the plain states from the Central Plains, from Iowa through Illinois into Indiana. So it's a pretty hot spot. The Ozarks and the central areas of Missouri may not have as many tornadoes, or it might be that we're not reporting them because there's vast areas of forest. And I know they have the question, if tree falls in the woods and there's no one around to hear it, does it make a sound? If a tree falls in the woods, it's probably a result of a tornado that went through, and that probably still makes a sound. Now, when we look at the deadly tornadoes, it kind of changes a little bit. We start to see a shifting a little bit further to the east. And what we're starting to find is that this area is very vulnerable to tornadoes. And when we look at how many significant tornadoes, these are really the strong tornadoes. We'll talk a little bit about that. That shows that this area is certainly the area of significant tornadoes. And what's really bad about this and what makes them deadly in this area is that a lot of these are coming in what we call the cold season, which means we're going maybe November through March before we actually get into the warm air. A lot of the times you get tornadoes that form at night, which makes them dangerous. There's people who live in prefabricated housing, what we'd sometimes call trailer parks or mobile homes. They're just not fastened to the foundations very well. And so the structures are not as significantly protecting people. They're strong tornadoes, they're happening at night. And so this becomes a very deadly place. So this is what we kind of slang name called Dixie Alley. So we have our more traditional Tornado Alley, maybe a second one across the plains, and then Dixie Alley. And when we look at where do people die, notice that the greatest percentage, the most fatalities are coming from mobile homes. And these are just not adequate structures to protect people from tornadoes. Now, permanent housing is still a pretty high number. So even though you have a well-built house, that doesn't necessarily stop you from losing your life. You have to make sure that you've got basements, for instance. So there's a lot of problems. And then vehicles are your third biggest scenario there. If we look at the 2020 tornado season, we see that we had a fairly low season. Now, this only went through September. We really didn't have a lot coming in here. So we ended up fairly below normal. And we can see the range of the tornado season. Here's the red one, which was 2006. That was a very active year where we ended up with 1,800 tornadoes, almost 1,900 tornadoes. In the last 20 years, we've gone a minimum in there of 944. Okay, so we're looking at some areas that are a pretty wide variety, but like I said, on average, somewhere around 1,200 tornadoes a year. Now, when we start looking at the deaths, this is kind of interesting. We are going back here to 1980, and we're not looking at that many fatalities. Now comes 2011, and this is a big fatality event, high fatality event where 300 some people died in one event. And that was in, if anybody knows, I'll give you the chance to guess your own comment here, but that would be Joplin, Missouri. That was a really big tornado event. So this number goes way high, and it sort of skews the record because we have this outlier. But the ironic thing is that when we get to 2018, only 10 people died, which is the fewest fatalities that the United States has had on record. So pretty impressive things that we're talking about. Now let's go to Illinois, because we said when the wind comes sweeping down the plains, and we're going to focus on Illinois. Here's the number of tornadoes, and you might say, well, gosh, we're starting to see the numbers of tornadoes going up. We start to see more tornadoes in the 90s and 2000s. Is this climate change? And the answer is no. What we're seeing is this is about when the movie Twister came out. And so in the 1990s, storm chasing started to become a thing. We started our storm chase program in 1989, and we were the first college group to give undergraduate credit to go tornado chasing. And we struggled for a couple of years as we finally started to figure it out, and things started to pick up. So we started to do a lot of this. But in 95, I think it was, Twister came out, and now everybody starts doing it. So there were tour groups that started offering tours for people to go chasing. Now, and colleges started modeling their programs after College of DuPage and started doing more and more. And now almost every meteorology college has some aspect of tornado chasing. And as a result of all the chasers and the spotters who are out there, we're seeing and reporting a lot more tornadoes, tornadoes that would never have been reported 30 or 40 years ago. Here's 1974, the big super outbreak of April 3rd and 4th, one of the biggest in history. That threw the numbers off quite a bit there in Illinois when we had a couple of big outbreaks that year. Now, to kind of prove my point about tornadoes is that, again, we're looking at tornado reports, and the blue is what we just saw. These are all tornado reports. But when we look at the significant tornadoes, so we are going to say we have what's known as the enhanced Fujita scale. Ted Fujita was a Dr. Tornado, they kind of nicknamed him. He was a professor of meteorology from Japan, worked at the University of Chicago, very famous. He's the one who came up with the damage scale that we measure tornadoes. It was called the Fujita scale, and it went F0 to F5. And then recently, in the last 20 years, we enhanced that scale with a little bit more information about what tornadoes can do. So now we call it the EF0 to EF5. But for the most part, it's about the same. And when we look at that number of EF2 or EF3, which is what we call significant tornadoes, so there's that number again, we see that the number of significant tornadoes is really not done much. In fact, if you do a statistical analysis, those significant tornadoes actually show a very slight decrease. I don't know if it's statistically that great of a decrease, but it is at least flatlined for the most part. So whereas we're seeing the tornado frequency going up, what we're reporting are the weak EF0, EF1 tornadoes, and that's a direct result of spotter information and chasers who are out there taking a look at things. So here it is, looking by tornado days by year from 1991 to 2011. And we're actually seeing that the number of days that have tornadoes is on a slight decrease. And so what we're starting to see with some climate change is that we don't have as many days. They tend to be clustered. So we get a little bit more outbreaks, and then we'll have several days with no tornadoes. It's noticeable. This is only a relatively short time period. So that's, I'm not sure how believable that is over periods of, let's say, 50 to 100 years, but at least it's something that we've noticed. Okay. Oops, let me do this. Oops, let me go back. So when we start looking at tornado destruction, this is what we would look at when we're looking at a significant tornado. The damage in here, the fact that the houses are destroyed. I mean, there's houses here. This is probably EF1 damage. We've got some of the walls coming down, EF2 or maybe EF3 in this area, where now we've got the inner walls only standing. But there's some houses where it looks almost cleaned off of the foundation. This is probably approaching EF4 damage at the maximum on this thing. So that's how we are able to view tornado destruction. Trees that are denuded, broken in half, wrapped around, just a lot of human tragedy when these tornadoes do hit, and they will hit. Something we always worry about is the school buses. This shows you what happens when you roll a school bus in a tornado. And I've taken video of buses driving away from a tornado, and I'm thinking, why are they out there? Tornadoes hit in the afternoon. Schools need to be really aware and have a really good plan to know what to do rather than send their students out in a school bus, because that's a really dangerous place to be. So here's a security camera video. I think this was in Iowa. I'm gonna let this thing run while I kind of talk over it. It's kind of fun. It's just a camera across the street on this house. And what you're gonna see is the winds start to shift directions as this tornado is approaching. A tornado is what we call a big sucky thing. So it's drawing air in. There's the change in the wind direction. And it's getting stronger, and it'll get darker as the tornado debris is kind of coming and overtaking an area. But you'll see how houses start blowing apart like that, and then they just disappear. This one is the strongest tornado that was ever reported in Canada. This is the Ellie, Manitoba tornado. This was rated an F5, and it's what we call a drill bit. And it's just amazing amounts of damage. So I'm going to show you this one. Now this is an entire house. And what makes tornadoes so destructive is not just the winds, because a hurricane can get really strong winds, but a hurricane's winds are completely horizontal. A tornado, and what makes them so deadly, is they have an amazing updraft of air. So things don't just blow sideways, they're actually blowing upward into the atmosphere. So this is a house. Houses are not meant to fly, so watch what happens. It just disintegrates. I'll show you something else here that I want you to see. Oh, shoot. Where was it? This is a minivan full of drywall, very heavy, flying through the air. I don't know, what is that, 80 feet in the air? This is why vehicles become so deadly. If it's lifting a minivan full of drywall, it's not the flight that's killing people, but it is when it lands, it will get smashed incredibly bad. And this is where most people die. It's in the landing of this thing. Now, there was nobody in here. In fact, nobody died in this tornado, so we'll let it go. But it's flying maybe 100 yards, 80 feet in the air. It's pretty impressive. So that was the Ellie, Manitoba tornado. Now, close to home, we do have the Fairdale, April 9th, 2015. This was in Northern Illinois. This was early season, right? We're almost there. This is a month away. It's a very sad story. This guy he and his wife did die, his neighbor died. Now, Clem is just an older guy. He was watching the video. What's amazing to me is that he doesn't say anything. He's just watching the tornado as it goes. He's up on the second floor. I don't know what his thought process was. I don't know if he was just watching it, if he was terrorized and petrified by it, or if he was just like, if it's my day to go, it's my day to go. His wife was downstairs in the kitchen trying to seek shelter. They did not have a basement. She did die. He got knocked out and was pretty badly injured, but he did not die. So this is what it looks like when an EF4 tornado is approaching your house. One of the things I tell my students is, if it's not moving from left to right and it's just getting bigger, it's coming at you. I don't know if you can hear the video or the audio. He's just breathing a little bit. You hear him a little bit. He's not saying anything. Starting to hear that roar that people often attribute to a tornado. And that was his house getting destroyed by the tornado, and that's how long it lasted. At this point, he's knocked out. I think the camera's still going, and they found it. And just an amazing thing that happens. So this is what the town ended up looking like a little bit after that. His house was one of these over here. Just an amazing, I mean, again, the video is amazing, but that's what a tornado does. So when we say seek shelter in a basement or the lowest room on an interior room, stay away from windows. You think windows are going to stop that thing? Get in the basement, seek shelter immediately when there's a warning, because these things are just not to be trifled with. So thunderstorms generally, here's the map. If we take a look, where are the areas of thunderstorms? You know, where do we get the most thunderstorms? Well, the mountains generate small scale climates that create thunderstorms. So you have the Front Range of the Rockies is one of the most active areas of thunderstorms. But the area that's definitely the thunderstorm capital of the country is down here in Florida, with well over 100 thunderstorm days a year, somewhere in Central Florida near Tampa. And I think it's ironic because the nickname of Florida is the Sunshine State. So that makes me laugh. If we take a look at other things from besides tornado, let's talk about lightning. These are fatalities of lightning from 1959 to 2017. And we're seeing that, sure enough, Florida is the #1 state in terms of lightning fatalities. We also have Texas, North Carolina, which makes sense. Lots of thunderstorms, a lot of people, a lot of outdoor activities where people are dying. Colorado, 148. That's where those thunderstorms are in the mountains. So a lot of problems. Illinois, 104 in about 60 years. So we get a number of fatalities every year by lightning. Now we do have ways of looking at lightning density by looking at our National Lightning Detection Network. And again, we're seeing the areas of Florida along the coast, that's your highest flashes of lightning per square mile per year. And Illinois is doing pretty well up here, though. It's got some serious lightning potential. Another thing, and this is a big one, is flash flooding. And flash flooding is the most common type of natural disaster. 40% of all natural disasters are flooding that are going on worldwide. So this is a big deal, very, very deadly. The water, especially when a flash flood, the idea of a flash flood is that this is 6 hours, within 6 hours of the onset of an event. Maybe it's heavy rain, maybe it's a dam burst, maybe it's ice jams. We have that in the spring quite a bit, where we get this flash flood going on. And so that's the kind of thing that causes so many fatalities. The river floods, which are bad and do a lot of damage, don't rise very rapidly, and so people don't die in river floods. We have approximately 200 deaths in the United States per year by flash flooding, and it's the leading cause of weather-related deaths in the US. People just don't take it seriously. Here's some idea of what happens when you've got flooding. A 10-year period from 1988 to 1997, it averaged $3.7 billion of damage a year. And something that I've been telling my students is that when you have a weather-related damage, there is no benefit that comes from it as a nation. It is pure destruction. We generate wealth from the creation of natural resources or people's brain to create something of value. Weather destroys value. Now, you have insurance, but that's still a cost. So that's just something to think about. $3.7 billion is wasted by flooding. And the only thing that wastes more money is the US government. But that was just a joke. Flash flooding. About 50% of all flood-related drownings are vehicle-related. So of those 200, over 100 people are dying in their vehicles because they drive through water. The Weather Service has come up with a motto: turn around, don't drown. And we're trying to get people not to drive through any sort of water unless they know firsthand that vehicles can pass. So they see somebody else. I've seen stories where people said, oh, I thought I could get through. I saw a car coming this way. I assumed they went through the water. But what they had done is gone to the water, go, I'm not driving through that, turn around and drive back. So unless you see the car doing it, and most likely you're going to see cars that aren't going to make it if you drive through it. So turn around, don't drown. When we have big flash floods, lots of rainfall. Then we start to get some heavy rainfall. Now, this is a cool event. Do you guys remember April of 2013? We had huge amounts of rain. Every place in Northern Illinois had 4 to 8 inches of rain. And there were huge floods. The Des Plaines River was badly flooded. The Fox River was flooded. Just huge rainfalls. And when we looked at the Illinois River, we set a record high of flood. So the flood stage is at somewhere around 18 feet. And we were over 10.8 feet above flood at the Illinois River. This was a really huge, heavy rainfall event tonight. Not sure if you remember that. Now, another convective hazard, or a hazard related to convection, which is what I mean by thunderstorms, would be hail. So here's severe hail. Now, severe hail is about 1 inch in diameter. That's the official hail report. This is a 10-year period. And we're looking at, there's Colorado with the big hailers, and Kansas and Nebraska. We look at Illinois, we're looking 6, 7, 8 hail days a year. So we get a pretty good amount of severe hail. Gives you some idea of this stuff. Now that causes crop losses of $1.3 billion and property losses of about $1 billion a year just from hail. And with storm chasers, it's probably even more than that. Now, when we start looking at hail measurements, 2 3/4 inch hail, that's pretty good. That's baseball hail. And that's really the size of a baseball. It creates updrafts in thunderstorms, the air moving upward of around 81 miles an hour to get 2 3/4 inch hail. And I've seen hail that's even larger, softball size or grapefruit size hail. So you're talking updrafts well over 100 miles an hour. Now we have windstorms. Here's a cool looking storm coming in the future. These windstorms affect us. This is a picture of an island up in the Lake Superior that's all covered in trees. These are all trees that have been knocked over by the wind. And they also made a sound, but significant damage, the blowdowns of forest like this. And when you have that, you lead to something called a derecho. Now, I would tell you that a tornado is a Spanish origin word, means to twist or to turn. So back in the 1800s, they were trying to get people to come to Iowa. And there were a couple of scientists. I don't want to hear about you, Siri. When you start hearing people going to Iowa, people were deathly afraid of tornadoes. And they go, no, these aren't tornadoes. These are just straight line winds. The winds are going straight down. And so they came derecho, which means straight ahead. And these are just big, strong wind events. Now, sometimes derechos do produce tornadoes, which makes it even worse. But derechos are these big, long-lasting wind events. So that's where that word comes from. Here's what we call the multiple state derecho that came back in, when was this, summer 2012, 2011, something along there. We actually had a line of storms that started right here. And it moved through. It did a lot of damage to Wheaton, Glen Ellen, Lombard, Villa Park, and Elmhurst. Did a lot of damage. Well, that line continued to progress, notice that the shape of this line is what we call a bow echo, but it's because it's long lasting, it's a derecho. This ended up going all the way into the Atlantic Ocean. It lasted for, what was it, 12, 16 hours, 450 miles with an average forward speed of around 60, 65 miles an hour. So these can be really long lasting, significant damaging events. That storm, when it hit, because it comes sort of as a surprise, there were areas of Wheaton and Glen Ellen that were out of power for 6 or 7 days. And ComEd actually won an award for a fantastic response. Because hurricanes come and do that same type of power outage, but we know hurricanes are coming, so people are able to deploy assets to the area that's going to be impacted. These things we don't know about more than if a half a day ahead of time. So everything is done in response rather than in sort of in response to an emergency. So rather than being able to prepare ahead. 450 miles in 6 hours. Oh, the average speed of this thing was 75 miles an hour. So this was June 29th, 2012. I forgot that I labeled it. Now here's the derecho we had last year in 1 hour time steps. Iowa really got the biggest brunt. They had winds somewhere about, 115 miles an hour. But this line came through, and I want to notice something here. If we look at this line, as it's coming through Illinois, do you see how it's not as defined maybe as it was here? It's a little bit more broken into areas. So even though we had sort of a continuous line, we started to get individual cells that produce short path and relatively weak tornadoes. But we did have a number of EF0s and even a few EF1 tornadoes. I did the survey, Wheaton and Lombard. Lombard and Villa Park were hit really badly. So I think there were 11 reported tornadoes. Eastern Iowa, funny thing is, they had winds to 115. That's EF2 damage in just straight line winds. Another big event was July of 2018, and we had a big derecho went through. This ended up hitting the lake, in some of the lakes down in Missouri. They had a duck boat accident. I think 17 people died as a duck boat collapsed. So what had happened over here is the captain of the duck boat saw this line of storms, and they're over here going, I can beat this line back to shore. Well, if you look closely, that's where it rained. This white line was what we call the outflow boundary. And this is where the winds were occurring. So poor reading of the captain going, this is where the rains are going to be. This is where the wind was. So it was just poor meteorology of the captain and the boat crew. But the Weather Service had been issuing severe weather. And this leads me to a little soapbox moment for me. I know you all have your smartphones and your weather apps, and you probably have all sorts of weather events. But I'm telling you right now, don't trust the weather apps. Listen to the Weather Service. You're going to be much better served by listening to what they say. The weather apps are tremendously not helpful. I hate them. And trust me, you're not a good meteorologist because your cell phone says it's going to rain at 3:07 p.m. Sorry, that's my soapbox because I see too many dumb things happening from it. So when we look at severe thunderstorm wind days, again, what's interesting is that we really have some of the highest amounts of wind out in this region, in the Appalachians, coming off of the Piedmont out here. A number of winds out south, but we still have a little corridor where we get maybe 1 or 2 derechos a year coming through our area. And we're still looking at a dozen days a year with damaging winds. So thunderstorms that can produce those damaging winds. This is in Kentucky. I found some good information there. I couldn't find it elsewhere. But the funny thing is we often will think of tornadoes as being the tornado season peaks sometime around April or May. And this is what the tornado season looks like in the US. But when we look at the significant winds, we actually see that winds are a late summer event. So when we start looking at our threat for serious winds here, we're looking at thunderstorms that are forming in June, July, and August, much more than the tornado season, which will probably say April and May into early June for us here. We can get them in March, but that's our tornado season, these 3 months. And then our severe winds are a little bit later. That's when we get some really big thunderstorms, just the tornado threat's a little less. We look at our average monthly wind speed, and this is what's going to be coming up next week with the big storm. So I'm giving you a preview. We actually see that the average wind, not thunderstorms, starts to go up as we go into March. So we're going to get some big systems in March and April. And Chicago is known for these big, it's almost going to be warm, and then the wind kicks off the lake. In Kankakee, it's 72 degrees, and along the lake shore at O'Hare, it's 34 degrees. And we get these big storms that come up there. It might be warm and thunderstorms, and then we get snow flurries and northwest winds. So our wind speeds are going up. As we go to the summer, the average wind speed dies down. So in the dog days of the hot summer days, we have the least amount of wind, peak a little bit in November and then go back down. But we're getting into what we would consider our windy season. So let's talk about winter hazards. Snow. Again, we had a beautiful day. I hope you went out and enjoyed it. The good news is we're past the peak. So the peak of our snow days, these are days with at least 0.1 inches of snow. Our peak season is somewhere in January. But notice that we still have plenty of chances for that all through March. And even when we start getting into April 1st through April 29th, we have between 5 and 10 days in this time period. So maybe every few years, we're going to get some snowfall accumulations in April. We had some really big events, somewhere between 6 and 10 inches of snow in early April a number of times. So being over here on March 3rd, we still have plenty of time for big snowstorms. So don't put away your snowplows yet. We also have ice storms. Now this is fun. These are big, bad events. They do a lot of damage to trees. I went through Paducah when they had a major ice storm with over 2 inches of accumulated ice. And I thought I was going through the largest tornado damage I've ever seen. Crazy, crazy amounts of ice that land on trees, knock down tree limbs, knock down trees. They sound like gunshots, knock down power lines, really bad stuff. And we look at the area, there's a pretty high frequency of freezing rain events through central Illinois. This was in Kentucky. We had one out here, if you remember, in the Carolinas. Then moving to Georgia, we got Augusta, where the Masters lost one of those famous trees due to an ice storm. Now, we talked a little bit about climate change. I just want to take a look here. This is interesting. This is our average temperature, January through December, over the course of time. And we are seeing that there is definitely a little bit of a trend of increase in our average temperatures over the last 120 years. That's a pretty long time. If we look at the last 100 years, the mean is somewhere around there. So we've gone up a little bit above average. So we're definitely seeing a little bit of an increase in the average temperature. And that corresponds to what we would consider climate change. Some of this is a result of natural changes, and some of them is anthropogenic, which means man-made changes. So we are contributing to changes in the atmosphere. And I know a lot of you are worried about CO2 in the atmosphere, but I'm going to give you a case that CO2 is not the only thing changing our climate. So we're taking a look at this average thing. Something I want to kind of say, because I think people don't have a good understanding, is that if you look at the variability, the peaks from year to year, it goes up and down. We have crazy variability, and we adapt to changes. When it's warm, the 1920s to the 1930s, that was our warm decade. You want crazy climate. The Dust Bowl years of the 1930s were extremely warm. Then we went through a period in the 50s and 60s where we were slightly cooler than normal. And now we have a couple of warm years. So just understand that when we talk about climate change is not the way that most people understand it. It's certainly not the way that you'll hear about it on media. So I really encourage you to take some courses or get some learning on climate so that you understand we do worry about variability, and we have to adapt to higher variability than this little average 1 degree change over the last 100 years in Illinois. So let's take a look at something else that I find interesting. When we look at precipitation, there's your average in red, but when we look at our linear increase, we're saying, wow, it's raining more across Illinois. Funny thing is, when we look at winter looks pretty flatlined. We do not see a higher amount of precipitation in winter. So what does that mean? It means our temperature increase is a result of summer. Summer precipitation is going up. Summer temperatures have gone up. And the reason for that is we are now planting more crops in Illinois per acre. The density of crop growth, corn and soybeans, is amazing. We're 4 or 5 times what we were 50 years ago. And an acre of corn in the summertime can put more water vapor into the air through a process known as transpiration than if that land had been a lake. So pure water sitting in a pond, it's going to put water into the air as it evaporates throughout the day. But that same acre covered in corn or soybeans is going to put more water vapor in the air. As a result of that water vapor in the air, we're now going to be able to rain it out with more precipitation likely. And that's going to come in thunderstorms in the summertime. So our thunderstorms are creating higher average precipitation totals. It's also changing the temperature because we're not getting the cooling at night with more water vapor in the air. So we don't see our nighttime temperatures in the summer as cool as they used to be. Daytime temperatures are not as hot. We used to get hot, dry temperatures well into the hundreds a lot. Back in the 1930s that happened. So we're seeing an average temperature increase and a precipitation in the summer, primarily because of the way we use our farm fields, our agriculture. So when we talk about climate change, you have to understand that it's not just greenhouse gases. It's also the result of how we use the soils, how our urbanization has impacted. So we see heat islands in Chicago, lots of things going on in that region. Now, one of the things that we look at are these things called El Nino. And really, if I could have figured out a way to find this easily, I'd put a little NEA in there, a little El Nino. El Nino means the Christ child. It's an event that happens in the Pacific Ocean. And when that happens, we have a warming in the Pacific. And we've seen regions of El Nino increases in the last couple of decades, at least from a small cycle. So when there's an El Nino, this is what happens in the winter. Well, does it get warmer or colder than normal? Well, sometimes it's warmer, but sometimes it's colder. So when people start telling you long-range predictions, I want to say, take it with a grain of salt. I'm not a big fan of that. We don't have a very good understanding. Now, this is what's going on currently, and this is where we measure the ocean temperatures. And now we're looking at temperatures over here that are colder than normal in this region. And that colder than normal temperatures say it's going to be a La Nina, the opposite. So rather than warmer than normal, colder than normal. And I saw this coming. And what I predicted was in early December, I said, we're going to have a fairly crappy, boring, non-eventful, not too cold, not snowy winter until mid-January. And then look out. And if you think about our winter this year, we didn't have much of anything through mid-January. And then the temperatures plummeted and the snowfall began. And our February was a very high level. We were close to the top 5 in a dozen different categories of cold, snow, longest days of heavy snow on the ground, measurable snowfalls. It was just a really brutal second half of the winter. To be honest with you, I haven't done much look at what's going to happen in the future with the spring, but I am concerned about this. We now have a drought monitor, so we're looking at a year of drought in the West, and what that usually means is the reason for that drought is our jet stream is doing this. It's a warm ridge in the West, and that tends to bring storms across here. And any place north of the jet is going to be cold. Down here it's been warm. Storm systems are coming here. It's been rainy. So this is pretty much what we're kind of expecting, or at least we had been expecting. Now, whether or not this is going to continue, we're seeing, remember we said the below normal temperatures? So what's kind of nice is we're seeing actually a change in the pattern that looks more like this with the jet stream. And that means this is cooler. It's going to be storm systems are going to track across the Midwest here along the jet stream. And so this area is going to become more active starting next week. So we actually have our first chance for some thunderstorms next week. It'll be fun. I love thunderstorm weather. I put this up on the site this morning. This shows you in the last 3 or 4 days how much rain we've had. Lots of rain across the south, Kentucky, a lot of snow melt, all that snow melt. And so what we're seeing is we're seeing some serious flooding going on along the Ohio River Valley, which will translate into the Mississippi later in the year. There's been some pretty significant flooding going on in that region, and that shows you why. So if you're interested in doing anything like this, we definitely encourage you to storm chase with us. We take out students, they come to us from all over the world, and we go from 18 to 80 has chased with us. So if you're interested, we'll eventually come back. I don't think we're going to be chasing this year, which makes me sad, but we'll come roaring back in 2022, if I'm not too old by then. But if you want to take a look at what we do with storm chasing, please take a look at this website there. So thank you for your attention, and I will open up to some questions that you may have, because most people like to talk about weather. George, you there with me?
Yes, I am here.
There you are.
You see me? Okay. Whoops.
The weirdest thing about presenting is that I'm just talking to myself. I don't see any faces. I don't hear anything. So now's the chance to ask questions if you have any that you'd like to know about.
Yeah, if you have any questions, just click on the Q&A at the bottom of the screen and type in your question. And Paul will do his best to answer it.
Here's something. Thank you, Terry. How far ahead can you predict weather? Okay, that's a great question. We are pretty good, and when you say you, I'm assuming you mean all of us. One of the things that is interesting is we're pretty good for 7 days and maybe to 10 days. In fact, let me do this since I've got my screen share. Let me go over here. I'll show you our webpage. We can look at models here. We have a long range model that we use for the jet stream, for instance. And we can look out, this goes to 16 days. Now at this point, I don't know what that means. That's 16 days out, but I'm pretty good for this time period, maybe out to 7, 8 days. I get an idea for the trend of the pattern. We have some reliability. Now I've been involved in a project that said, let's try to do severe weather for 2 and 3 weeks out there. We have some ability over guessing. That's how we measure our skill. Can we do better than a guess? We have exhibited some indications of basic trends. Like for the United States, there'll be more tornadoes in 2 weeks or 3 weeks. When we start looking at months, 1 to 3 months, this is where we start to be pretty bad. There are some people with skill. We're not always right, but there's some things that we can kind of address. And the idea of forecasting in the long range is there are things we know, and there are times we know we can know it. There are other times where there's high levels of uncertainty. And that uncertainty is still well beyond our ability. So we have some skill 1 to 3 months. Beyond 3 months, I think it's lousy. I think 1 month is lousy. Sometimes we have some skill in 2 to 3 weeks. We have a lot of skill in 1 week. So that's the answer to that question. We talked about cloud seeding here. So I haven't heard, well, you know why? Here's the thing. When you can sue somebody for changing the weather, you don't want to go messing with cloud seeding. Now, there are cloud seeders that go through the Dakotas. In my opinion, they mess severe weather up. I don't know if they're good or bad. They can affect a thunderstorm, but I don't know if in the long term it's good or if it's bad. There are some indications that hail gets suppressed, but it also may limit the amount of rainfall, and farmers want rain. So there's only very few areas that deal with weather modification, such as cloud seeding. Do I expect an active spring tornado season? You know, Laura, that's a great question. And I've been so busy dealing with my classes online that I haven't really thought that far ahead. Next week, you know, we've had a very inactive season so far. Next week is our first chance. where there might be something in the Tuesday through Thursday timeframe, at least in the nation. It's not a really good setup. There's a little bit of moisture lacking. So it may be a decent year as we go into April and May. And I'm going to start looking at that now that we're in March. But I don't see anything at this point that I would say one way or the other. Does any nation try to manipulate? Well, yeah, they do a lot of local manipulation, but these ideas of large scale government, no, that's not happening. We try to do fog mitigation. We can affect seeding in thunderstorms. We try to do something along those lines, but the large scale is really, it's extremely young science, so I do not hold anything in there. We can predict the weather based on El Nino or La Nina to some extent, but we are really bad at it. In fact, I went to a conference back in 1997. There was a bunch of scientists that said, we can predict El Nino. And then 20 some years later, after making that big announcement, they said, we owe the public apology. We can't predict El Nino. So we get some seasonal ideas, some viewpoint, but it's not nearly as good. We're talking like 5 to 10% above normal. We're not talking about really good weather. We're not looking at weather predictions. We're looking at seasonal predictions. And there actually has been a push to try to get more funding for seasonal weather prediction. And I don't know if that's how well that's going to happen. That's what we're messing up with. Does it provide more reliable weather forecasts versus popular weather apps? Here's the thing. The popular weather apps are okay. I mean, I certainly have them, from the Weather Channel. I go, oh, what's the temperature next week going to be? What I'm worried about are the apps that say it is going to rain at 4:08 p.m. There's going to be a thunderstorm. Those things are just ridiculous. So what I try to do is there's models that we can look at. I can give you some really great model forecasts here. It's high resolution models, which is where most of these things are coming from. And I can show you over the next several hours what the temperature might be across the plains with some detail. So this is good stuff at our website, but I would stick with the National Weather Service. By the way, I think the Chicago area Weather Service is one of the best in the country. They are phenomenal. So if you just go, if you want to do this, we have an Illinois page. These forecasts come out from the Weather Service, and this is what I look at. I look at that and I go, this is much more reliable. I'm not going to get specific. I'm going to say highs in the lower 40s tomorrow. Are storm chasing terms nimble enough to avoid getting hurt? Well, here's the problem. Like our class, we focus on safety. We can be nimble enough. I run a tight ship. There's inherent danger to being out of storm chasing. Tour groups, people are getting a little bit crazy, in my opinion, and they're running the risks. And there's been tour groups that have been hit by tornadoes and have had significant injuries of their participants. So I'm not a big fan when they're playing loose with the weather. So I'm a little bit more cautious. I hold safety more than experience. Like if I feel like you're in danger, we're not going to do something. We get close, and we've gotten really close, and it's been very exciting. And there are times there's a limit to what we know about tornadoes, about storm chasing. So we try to respect them a lot more than some tour groups. What's the best place to live in the US? I love that question. Who's PB? Yay, that's a great question. I would say Wichita, Kansas. That's where, if I could pick a place for weather, I would say Wichita, Kansas. They get winter, they've got good storms in the spring, and their spring starts in March, and I hate March, and they still get winter. So I think that's really good. As I get older, I'm thinking further south. How does Lake Michigan affect the weather patterns here in the western burbs? Oh yeah, okay, so the lake, because it's cold in the spring, tends to prevent warm air from coming up north. So sometimes we get what's known as a backdoor cold front, that the cold front will actually come in off the lake, and it messes up your forecast. You'll be like, oh, the forecast is going to be here. Let me show you one. You want to see this? I'll show you this. I like talking about weather anyway. So I'm going to show you one for Illinois, and I'm going to look at temperatures for the Midwest. So we can zoom into Illinois, and we see our temperatures going 44, and then we start seeing yellow. We're like, ooh, look, warm, right? 60s. This is on Wednesday. That's what we're hoping for. And then we drop off temperatures. But there are times where we go, oh, the 60s are coming, and the winds turn off the lake. And we get this backdoor cold front, like the winds coming off the lake, where temperatures down here are warmer and the temperatures on the lake. So that happens. They can produce lake effect snow. We've had Midway this year, right? They had that day where they got 16, 17 inches of snow. That was a lake enhanced snowfall. Probably a foot of that snow came because of the lake. It keeps us warmer in the winter, but it's colder in the spring, and it's brutal. So even here in the western suburbs, if you ever want to look at weather maps, look at Waukegan. Waukegan winds go northeast and the temperatures drop. The next one might be Milwaukee Airport, or what do they call it? There's a name for that airport. I can't remember. It used to be called Milwaukee. And then O'Hare goes down. And when you start seeing that cold air coming, DuPage is going to hit. It's going to drop. So the central parts of DuPage, it'll go all the way to Kane County, out maybe to DeKalb County. You want to get your husband out of the house. Okay, Laura, there's still some snow. I have some snow that could be, I like it to disperse it, so you can send him over to my house and get him out of my house. Next week, we are going to get, we're hoping that this model is good, right? This is good. We like to see this temperatures where if you look at our temperatures, these are all up in the 50s and 60s. I would love to see that. But whenever we get warm air in March, two things chances for thunderstorms go up and it will turn cold again. So it's not spring, but we'll at least get flavors of spring. I have a kind of a cool thing I can show you from Iowa State that just shows you our temperatures for the next 7 days. So here's the temperature forecast. We got pretty warm today, probably warmer than expected. But all the different lines show you the variation in the temperature forecast. So when we look out here next week, we're looking at temperatures that are fairly warm, temperatures above 60 degrees maybe. But then look what happens as we go into Wednesday night into Thursday. See the temperatures starting to plummet, and that's what we're going to be looking at. So any other questions? Getting to the end of our talk here, so you're welcome to write to me anytime. I can go back to my email over here. Feel free to send me an email. But thank you for giving me the opportunity to talk. Welcome to severe weather. Be careful, pay attention, get weather radio if you have that at home. Find a way to get, your phone's good for getting warnings. So weather apps are fine. Just be careful what you trust. Okay, I like the ones that tell me about what it's going to be, and I like something coming from the Weather Service. That's my own personal take on that. So